So, let me just see where this is. So, it is going to lie in the saturated region. So, let me write down all of these values. So, I am looking at 0.4 and 0.6, I am going to take average. So, 0.4624, 0.3156. This will be my Vf. I am taking value at 0.4 megapascal and 0.6 megapascal and dividing by 2, linear interpolation essentially. And Vg I am going to take 0.4624 and 0.3156. So, that is sorry, I have written Vg values here. Vf I need to take 0.001084 and 0.001101. So, I actually have a value of 0.33 meter cube per kg. It lies between these two. So, therefore, it is greater than Vf. So, it should be on the right hand side of the diagram. It is less than Vg. So, it must be to the left of the. So, if I was to draw for example a TV diagram. So, at a pressure of 0.5 megapascal, this value is 0.001132, this value is 0.389. So, the value I am looking for is 0.33. It lies to the right of this because it is greater than this value. It lies to the left of this because it is less than this value. So, it must be somewhere in this region. So, since it is in that region, I can also find the quality associated with it. So, in a similar fashion to what we have done earlier. So, V1 is 0.33, Vf is this, Vg is this. So, I am going to directly find out what the value is. This gives me a quality of 0.847, which is the dryness fraction. So, I know everything about the initial state now. In the final state, it says it is a constant pressure process. So, which means P2 is 0.5 megapascal. It says the temperature is 300 degrees centigrade. So, let me go back to the table which I had. So, at 0.5 the temperature would be the saturation temperature is between these two. 300 is much higher than this. So, 300 degrees centigrade is much higher than Tsat at 0.5 megapascal. So, therefore, state 2 must be in the superheated region. So, I need to go and find out the superheated values. So, what I know is that this is a constant pressure process. I am asked to find out the work done and the heat transferred. So, the work done in the constant pressure process would be equal to the work done for the constant pressure process would be essentially mass times, sorry, the heat transferred would be this. The work done would be essentially P dV, because P is constant. And what else are we asked to find out? We are asked to find out work done and heat transferred. So, these are essentially what I need. What I can also do is I can find out delta U, which would be mass times U2 minus U1. So, I can either find out these two directly in this fashion, or I can find this and use first law, which tells me that this. So, I can find it out in any of these ways. So, I can find out these. What I will possibly do is stick to this. I know the mass, it is 0.6 kg. I need to find out enthalpy at 2. So, the state 2 is 300 degrees centigrade and 0.5 megapascal. So, I am going to try to find out that from this tables. So, I know it is in superheated region. So, let me go to the superheated tables. I am looking for a pressure of 0.5 megapascal, that is here, and I am looking for 200 degrees centigrade, which is here. So, I am interested in these values. So, the volume is 0.4250. So, V2 is 0.4250 meter cube per kg. I need that for this. Let me find out enthalpy. Enthalpy at 200 degrees and 0.5 megapascal. The enthalpy is 2855.8 kilojoule per kg. I need H1. Yes, and since we did not have that value directly, I need to find out HF. I am going to take the average, and Hg also average of the values from 0.4 MPa and 0.6 MPa. So, let us find that out. So, the what we are finding out is 0.5 MPa and saturated conditions. So, we go back to the saturated chart, we will look at the values by the pressure table here. So, I need values of enthalpy. So, that is 604.7 and 670.4. Here what I am looking for is actually HFG, which is essentially, where are we? Here, these two values 2133.5 and 2085.7. This is here, this is here, and I have x, which we found as 0.847. So, we have the enthalpy initially as this value by substituting this into this equation, and the final enthalpy we have as this value. So, I can subtract these, which gives me this value as 0.66 in. So, I have here 2855.8 minus 2424 which is 258.8 kilojoule, and work is constant pressure process. The pressure is 0.5 megapascal. So, that is 0.5 in 10 power 6 pascals into V2 minus V1. So, this is P into M into small V2 minus V1. This is P into M. So, I have the specific volume is 0.4250 and V1 I had from here as V1 was 0.33. Which is 28 kilojoules. So, this is essentially what we get as the work and heat transfer. So, we will stop here for this class and we will continue later. Thank you.